Okay, so Terry Vogel, an amateur motorcycle racer, averages 129.71 seconds per 2.5 mile lap in a 7-lap race with a standard deviation of 2.28 seconds. The distribution of her race times is normally distributed like the bell curve, right? We are interested in one of her randomly selected laps. This is the logbook of Terry Vogel. Let X be the number of seconds for randomly selected lap. Random answers to 2 decimals. Okay, so you know how we start. This N stands for normal, normally distributed. We always put the mean here, the standard deviation there. What's the mean? The average is the mean. 129.71. Standard deviation, there, 2.28. Okay. Now, find the proportion of her laps that are completed between 127 and 130 seconds. Okay, so that's not too bad. That'll be pretty straight ahead. So we just draw the bell curve. Put the middle on there, the mean, which is 129.71. And then it's saying, okay, we want between, what is it, 127, about here. And then I'll put right here, 130. So we just want the shading between 127 and 30. So they're saying find the proportion, find the percentage. So that's always normal CDF. You can go to the exam notes here. I'll go up here real quick. So this is the exam 2 notes. When they ask for a percentage, right, they're asking for a probability, which is a percentage. Normal CDF, left, right, mean standard. So that'll be normal CDF. So we'll go second, bars, normal CDF, and we'll go lower. A little scribble there. Lower, upper, mean, and standard. So the lower is the 127, the upper is the 130. Right? Whenever we say lower and upper, we mean the left edge of the shading and the right edge of the shading. I mean, it's all about the shading, right? What we've actually shaded. So we mean this left edge and this right edge. That's what we mean by lower and upper, left edge and right edge of the piece of shading. And the mu, that's just the mean, you know that right there. And the weird looking circle thing is standard deviation. So the mean 129. So one standard deviation is 2.28. Let's type those in, hit the buttons on your calculator. Make sure you round all answers to 2 decimal places. So make sure you round to 2 decimal places. I'm going to go on to part C because C and D are more interesting, more challenging. I want to show you those. Fastest 2%. Fastest 2%. Okay. So let's think about that. How are we going to do that? In fact, you know what I need to do? I need to get a fresh copy of this. This thing is getting dead slow because it's got too much on the page. Let me grab a fresh copy. My iPad's starting to lag down when the file gets too big. Quiz chapter 6. Here we go. All right, we've got a fresh, snappy one. All right, here we go. Awesome. Grab it, move it down, and it won't hold me back anymore. I'm starting to lag my writing. Slop it up. Oh, come on. Here we go. Here we go. Okay, so now on part C, the fastest 2%. Now, let's draw that. So the fastest 2%. So here's the middle, which is 100, average is 129.71. Okay, so think with me now logically on this one. Where is the fastest? Remember, up here are bigger times, like this might be 140, 150. Down here, smaller, like 120, 110. So remember, that's how many seconds. This is seconds per lap. Are you with me on that? Let's keep one foot in reality. Let's remember, we can get so tied up in the numbers that we forget what we're actually measuring and doing here. We're talking about this motorcycle racer and how fast she can do a lap. And her average is just under 130 seconds for a 2.5 mile lap. And so that's her average. And let's find out, where is the mark for her fastest 2%, the one she does the best on, her fastest 2%. Well, fastest, is that going to be higher times or lower times, right? Because these are times, these are seconds down here, right? This line is all about seconds.
Would it be lower?
Lower times, huh? Yeah, exactly. So in other words, we're talking about way down here, 2%, which decimal is 0.02, because that is fastest. Fastest meaning lowest times, huh? If you're racing faster, you have a lower time on the track. So they're one. Now, I don't really know it's 110. I just put that there random just to show that, smaller numbers are to the left, bigger numbers are to the right, aren't they? So that's our whole job, is find out exactly what is that number. How fast does Terry Vogel have to race to finish the track so that she's in her fastest 2% section? That's what they're asking us, right? Her fastest 2% are under how many seconds, right? So this is 129 in the middle. That's her average, right? 129.71. That's her average. If she goes above that, like 130, 140, she's going slower than average, right? Longer time to finish up. So maybe this is down like at 120 seconds. I don't know. Maybe it's 115. Maybe it's 125. I don't know. Something below 129, isn't it? What is the mark that puts her in the fastest 2%, the lowest time 2%? How do we find that? Well, notice they're giving us a percentage. You go to the exam notes. Here, let me show you those real quick. Here's the exam 2 notes. Notice when, we don't care about these yet. So when they ask you for a percentage or give you a percentage, well, in this one, they're giving us 2%. So we'll do inverse norm. So let's do that. So on this question, we're going to most certainly do second. This is part C. This is still part C here. I haven't done D yet. Second vars inverse norm for sure. Okay. And they always ask for area and then mu and sigma. Okay. Now what is area? That's going to be our 0.02. Why? Because that area always means area to the left. Right? For the spot we're trying to find right here, we're trying to find this spot. This is what we want to find. The area to the left of that spot is 0.02. And then just put in the mu. That's the 129.71, the center. And the standard deviation, I don't remember, whatever it was. Oh, there it is, 2.28. How much variation there is from one race to the next. That's the average distance from the middle on her track times. So put that in and you'll get the mark for her fastest 2%. And now question D is the hardest of them all. On question D, they want us to find the middle 30% of her laps. That's always the hard part when they do that. So let me bring that down. Let's do that carefully and draw that well. So for part D, the middle 70%. Okay, so how we do this? It's all about drawing a good bell curve. Draw a good bell curve. Not a bad bell curve. That's a bad bell curve. Do a bad one. Well, my hand just gets shaky over there on the right side. All right. So I'll put the middle on, whatever the middle was, 129.71. Okay. So you draw the bell curve. Now the middle 70%. Well, let's draw that. So that means like from here to there. So that this chunk in the middle is 0.70, right? The middle 70%. So I want to find this mark and this mark. That's what they're asking me. What are the times? How many seconds to how many seconds for the middle 70%? So what is the middle 70% of Terry Vogel's race times? You know, from where to where? Is it like, because this 129.71 is the middle. So maybe this is like 120 to 140 or something. I don't know. I'm just guessing, you know. How many seconds, like if she goes from 120 seconds to 140 seconds, maybe that's the middle 70% of her lap times. That's what she does in the middle 70%. I don't know. We're going to find it. How are we going to find it? Well, if we go to the notes, it's going to be inverse norming. And why? Because they're giving us a percentage, right? They gave us 70%. So it's inverse norm, area left, middle, standard. Okay, so let's first find, this is the, this is the lower, this is the upper. So let's first find the lower. How do we find that? We're going to go second, vars, inverse norm, right? And then it's going to say area, mu, sigma. Now, what does that area mean? To the left. Remember, it's area to the left. So if you want to find the lower spot, you got to find out how much area is to the left of that spot. Well, how are we going to do that? Think about a candy bar. My analogies are always candy bars, right? This bell curve is a big old candy bar. And somebody just ate, I did, Mr. Heron enjoys candy bars, 70% of the middle right out of it. So it's a little gross. But if I ate 70% of the middle out of the candy bar, how much of the candy bar is left on the two ends? 30%, right? So you take 100% minus the 70% that I ate out of the middle. That's 30% left, or 0.30 left for both ends.
So you divide that, 15?
Yeah, you got it. Divide by 2. That's 0.15 for each side. There's 15%. So there's got to be 15% here and 15% of the candy bar there, right? For 30 plus the 70 is the whole 100% of the candy bar, right? So the area to the left of this lower spot is simply 0.15. Put in the mu, 129.71. Standard deviation, whatever that was, I don't remember, 2.28. Hit the buttons, and that'll give you the lower, okay? But now, how do we find the upper? Well, it's very similar. Now to find the upper, right here, this upper spot, again, we're going to go second, vars, inverse norm. And then, again, they want area to the left. Remember, it's area to the left, and then mu and sigma. What's the area to the left of this upper spot? What is all the area to the left of this upper spot? How much of the candy bar is to the left?
70
85? And 15. 85. Yeah, exactly. It's going to be, let me just do it right here. 0.70 plus 0.15. 0.85. Yeah, so you're always doing area to the left. And so the area to the left of the upper spot is 0.85. And then same old mu, same old sigma. 129.7. You're just telling the calculator what the middle is, what the standard deviation is. But most importantly, you're telling the calculator how much area to the left. So you've got to find the lower and the upper separately. It's like two problems in one. Because for the lower, 15% of the candy bar is to the left. For the upper, 70 plus 15, or 85% of the candy bar is to the left. And that'll find you the upper value. So those are more tricky for finding lower and upper. There we go.